When GWAC began in 2005, the whole goal was to educate people about climate change. Educate, educate, educate. There wasn't much happening on the front of the state or the federal government. People were mentioning it, but nobody was talking about it. So we kept going on with the science-based education. We got to a point like 5-6 years ago, we said, you know, we're done just educating. Right now, every education has to come with an action because we all can do something. So EnergizeLexington.org, which I mentioned earlier, is a platform that these groups came together, LexCAN, a few other groups, and we hopped onto a platform created by Mass Energize, which was basically about all of these kinds of sustainable choices. And on that platform, you can go there and learn about how to install solar, learn about some of the solar installers in the area. Same thing with heat pumps and any other sustainable action you can take. And one of these other towns had done these home tours, and they called it Earth Day All Over Town. So we combined that with, we had a hub where we had some vendors showing things. We said that's a great idea because sometimes people want to do these things. They just don't know where to start. And if they know their neighbors are doing it, they may do it too. We got an email from the Summers who live in the house that's being renovated. And they said, oh, we're doing this and this and this. And Rachel, who is the owner in that house, said, is a member of the LPS Green Teams, which does composting in our school systems. And it would just, you know, fell into our lap. Todd Berger, who lives next door, he's a friend. I knew he had done this apartment, and he said, oh, I'd love to show the apartment too. You know, it just was happenstance that this building was going on at the same time, and the apartment was right next door. And the builder who is doing the building was willing to be recorded, as you'll see in the video, as was the HVAC person, because they're proud of what they're doing, because they're learning a lot too.
My name is Todd Berger. I live here with my wife Deborah. I lived in Lexington for the last 32 years. We have a barn behind the house, and the barn has been on this property for, a barn has been on the property, we were told, for about 150 years. This particular post and beam barn has been there for 85 years. The barn was really falling apart. We had a leaky roof. We had a resident raccoon I used to run into in the barn on several occasions. We have 2 electric cars, so we needed a new electrical service at the barn. The barn needed a new roof and many other things, and we said, if we're going to do this, let's do it right. And so we spent a lot of time planning what we wanted, and we had several goals. One was we did want to preserve the post and beam barn. The cheapest thing to do probably would have been to tear it down, but the post and beam construction was attractive, was functional, and if we could preserve that, we wanted to. Secondly, we wanted to end up with something that was environmentally responsible. So for us, that meant a building that consumed very little energy, and also a building that involved using the least amount of toxic materials, if possible, none. And so that drove a lot of design decisions. We also wanted the building to end up like it looked like it belonged there, like it had been there for decades, that fit with the house, that fit with the property, and that fit with the neighborhood. And that also drove several design decisions. From the very beginning, my wife and I wanted to take back about 4,000 hours of work, probably me more than my wife. And I have a lot of carpentry skills, electrical skills, and others that you'll hear about as I describe the project. And so we needed to find a builder that would be willing to work with a homeowner that wanted to do that amount of work. We also needed to find a builder that was not shy about using some newer technologies that would make the building be more energy efficient and have less toxic materials than is typically the case. And we found a great builder to work with us, Platt Builders out of Groton. They had a bunch of subcontractors. I also had some subcontractors working for me, and then I did quite a bit of the work. So part of the aim of the project was to take a building that you could only park 2 cars in end to end. You couldn't close the doors properly. They were old style, big barn sliding doors, hence the visiting raccoon. to something that was really an airtight building, that the cars were well protected and in a warm place for the winter, and make the space above the parking area usable. And so our idea was to have an apartment above that. Someday, my wife and I think, maybe we'll live in the apartment and we'll rent the house, or if we're here in our late 80s and 90s, maybe we'll have someone helping us to stay in place in the house, but a caregiver who could be living in the apartment. In the meantime, the idea was to rent the apartment to give us some more income to be able to stay in town, and to do this all environmentally in a responsible fashion. So for us, that meant, for starters, nothing combustible in the building. We didn't want natural gas, we didn't want propane, I didn't want gasoline in the cars, I didn't want yard tools that had gasoline. So we said we're going all heat pumps in the building, all electric yard tools. And we started talking about insulation approaches, and I'm not a big fan of foam products which can give you high R values, but they do have off-gassing, they do have use petrol products in the manufacturing, so I wanted something that was not that. And we ended up with, the other thing we're after was a complete insulation envelope around the building, which very few buildings in Lexington have. We have it in the barn, our neighbor's house now has it. When you do that, you eliminate what's called thermal bridging, where the heat or cool in the house goes right through the studs to the outside of the house. With an insulation envelope like we have that's continuous, you not only get a better insulated building, it's much quieter inside. If there's any busy roads near you, you don't hear any of that noise. And so we have rock wool on the outside, 2 layers of 2-inch rock wool on all the walls. In the roof, we have 2 layers of 3-inch rock wool. It's called comfort board. But then we have another 6 inches of dense packed cellulose in all the walls. We have 8 inches of rock wool batts between the rafters and the ceiling. So we have R values that are well in excess of the stretch energy code requirements, much less the old energy code. We have R33 or 35 in the walls and R52 or 53 in the roof. We also have an insulated floor, and we even have what's referred to as a thermal break between the part of the concrete pad of the garage floor that extends outside the doors, so that the coldness or the heat does not transmit inside the building in peak temperatures or low temperatures. So all of those things gave us a low energy cost for the building. There's also every single light fixture inside the building, outside the building, and in the apartment are all LED light fixtures. There's a full laundry in the apartment, and the dryer, most electric dryers require a 240 volt circuit, and usually a fairly high amp, usually 30 amp circuit. We have a heat pump dryer. It requires only a 15 amp 120 circuit to run. It has its own condensation drain, so it does not throw the moisture back into the apartment area. And it's worked so well, our tenants have just ordered them for their new house. We also have a heat pump hot water heater. So it's not a straight electric heater. And that heat pump hot water heater is located in the lower section of the barn, in the car parking area. And all of those things have produced a roughly 1,100 square foot apartment that has a total energy bill for heat, cooling, lighting, hot water of about $1,500 a year. With a single tenant in there, we'd probably see something closer to $1,200, and with 4 people in there, it'd be closer to $1,600, $1,800, but that is for the whole year, everything. Some of it is fairly innovative, but honestly, there are places in the country that do more of this kind of thing than is currently happening in Massachusetts. There was a lot of planning there. I will tell you, there are lots of builders and lots of HVAC contractors, heating, ventilation, air conditioning contractors that don't know about the things that we did. For example, one of the things that Platt Builders helped us with, to get a tight seal on an existing building is very hard in a renovation project. It's very difficult to do that. However, what we did, every single place that a wire or a pipe or a tube of any sort or an air duct goes through the wall surfaces or the roof surfaces, There's not just a flashed gasket, it is a rubberized, that lasts for 50 plus years seal, tight seal on every penetration into the building. As a result of that, we've got a test, a typical house leaks about the equivalent of 4 whole air changes per hour. That's how much air is around doors or under doors, around windows, pipe entrances. That's what a typical house does that was built even in the 1990s, early 2000s. So when you get down below 2, that's pretty good. When you get down below 1.5, it's really good. In brand new construction, spending the maximum amount of money to get it, you'll be lucky to get down to about 0.4, 0.5. We got down to 1.1, and then we found an air leak under a door, which we've since fixed. We haven't had it retested, but my guess is that we're probably at about 0.9 air changes per hour, which just means you're not heating air in winter and then letting it leak out through someplace, or you're not cooling air in summer and letting it leak out. It's a very tight building. The building also got what they call a HERS rating, H-E-R-S rating. Our builder had never seen a HERS rating below 45 for a renovation project. We got a HERS rating of 39. And it wasn't by accident, it was by doing all these things in planning. I mean, for example, before any finishes were in the apartment, all of the walls were caulked and sealed so there was no air movement between the apartment and the garage. They were actually sealed on both sides of that envelope. So there was, to answer your earlier question, there was a lot of work done to think through what materials we were going to use, how they were going to be installed, and what was going to be done in those installations. And our builder, and it's important to say this, I think, you need to find a builder who is willing to take the time to do it right, which does not mean that you're necessarily going to spend more, but you're going to deal with a builder who doesn't mind reading the manual, the inspection, the specifications for how to use this new material they haven't seen before. When we started the project, before we started the project, and we had settled on that outside insulation called Comfort Board, our builder called the manufacturer, set up a date and time, had the manufacturer's rep come to their offices and train their crews in the do's and don'ts of doing the installation. A lot of builders just want to come and do what they did 6 months ago at some other place with some standard material they've used before. But you do that planning right, and it went very well. Our siding is all Nova Scotia fast growth cedar, pre-primed at the factory, same as we have installed in our house some years ago. Our house hasn't been painted in 17 years. We had a painter here looking at it, and he just refused to paint it because he said, your trim needs some painting, but your siding's good for another 5 or 10. You do the right planning and install it right, you're going to end up with lower costs. On the energy side, yes, I think it is a replicable model. In fact, it's so replicable that when our neighbors saw this building go up, they changed their plans and got rid of natural gas and said, you know what, we're going to heat pumps and we're going to this outside insulation envelope on top of inside insulation, and we're going to drive our energy costs way down. And they found they're actually using a different builder than we had, and they are doing a great job using those same materials to have that same positive outcome. I think, if you look at what's going to happen to what's already happening today, but even irrespective of current political events, what's really going to happen over the next 10 or 20 years to natural gas and propane prices, people that aren't looking at air source heat pumps today are really missing the boat. There's a great opportunity to reduce energy costs with air source heat pumps. And people who looked at them 8 years ago, it's time to look again, because the air source heat pump, for example, that we have on this building, it's called a hyperheat whole house heat pump. So I'm not talking about a mini split, but where you have to put 4 or 5 on a building, but a single whole house unit that can feed zoned units within the house, the potential to drive down your energy costs. Those things can now operate to 5 degrees below zero efficiently. If you have 2 days of the year where it goes below that, they have electric grid override. It's still an enormous savings over having natural gas or propane. We did get some state energy rebates related to the windows, the heat pump, and a number of the other energy measures that we took. There's one thing I haven't mentioned that actually got a lot of interest on Earth Day in May in Lexington. In fact, I would say almost every single tour of people that I took through the building that day stopped and took a picture of this thing that was introduced to us as a technology by our neighbors. And I looked into it, and it's a little device that gets added between the water line for the washing machine and the washer itself. And what it does is it takes the incoming water to the washer and it creates ozone in the water. And as a result of that, you don't need detergent. Well, from a landlord point of view, I like the idea of no one having to haul detergent and maybe spill detergent on my nice wooden floor in the apartment. The tenant liked it because actually ozone-treated water does a better job cleaning than laundry detergent. But that also meant they didn't have to pay for and lug those bottles of laundry detergent into the apartment, or to put that plastic into the recycling stream or the trash stream, wherever it would end up. Sometimes you put it in recycling and it doesn't even go there. So it's a little box about 6 inches by 18 inches by 3 inches, and it's been working flawlessly. And I would highly recommend people look at that for their own. And it's an add-on you can get. You don't need a different kind of washing machine. But it's another environmental benefit of the building. Well, I certainly hope that in the next decade we see a massive switch from oil and propane in this town and natural gas to heat pumps. And I hope Lexington is, because of LexCAN and Mothers Out Front and other groups, Energize Lexington, is one of the towns leading the whole state in that direction. It'll be good for the town, it'll be good for the residents, it's good for air quality, it'll be good for the country, and it'll be good for the planet. And it'll be good for people's pocketbooks as well. Even without the rebates that are out there, some of the things I've talked about have really fantastic paybacks. You know, we could have an apartment out there that was consuming 2 to 3 times what we're going to be paying in electric bills in terms of energy costs for the building. When people start looking at what their bills are and they add up their electric bill and their oil bill or their natural gas bill, and then they think about what it would be like with a heat pump. Oh, and by the way, I didn't mention one other thing in the building. If you build a really tight building, there's something else that you really ought to have, and it's called either an energy recovery ventilation unit or a heat recovery ventilation unit. And what it does is, it's good to bring in fresh air to a building, but it's good to do it in a controlled way where you don't lose the coolness of the apartment in the summer or the heat of the apartment in the winter. And a heating or energy recovery unit brings in fresh air, and there's a transfer of energy between the outgoing air and the ingoing air. So that unit has an HRV with HEPA grade filters on it. So not only is it a low energy cost building, but it has some of the best air quality of buildings in town. I think the only other building I know of that's got as good air quality is the new elementary school the town built, thanks to our selectmen and the town's energy advisory groups, which also has HEPA filters on it. But that was another element in the design.
I'm Joshua, and this is Rachel, and this is our Eco Build. We're doing a home renovation project, and we're trying to incorporate as many different green features in the way that we construct it, and ultimately the finishes we decide on inside it. I really credit Rachel with pushing me to think about a lot of these things more critically. She's started from the outside in the landscaping and how we've incorporated a lot into the property, and as we started to go on a project to really rethink the way that we were living in the house, you challenged me to think about every single thing we did. How could we better insulate the home? How could we really move to 100% electric-based living? And ultimately, how can we choose products to finish the house off that really have minimal impact on the environment?
Well, I'll add to that, as we're making our house bigger, trying to think about how to balance that and not have a bigger impact as a result. I think one of the things, so we put geothermal heat into our house 10-ish years ago when it wasn't very common, and had the realization that the way we did it with an existing house was not necessarily cost effective, but we'd had an oil spill at our old house, so we were going more for karma at the time. But in looking at the numbers, we wondered why more people weren't doing this for new construction when it actually did make financial sense, and just that the knowledge wasn't out there. So as we got into this project, listening to more things, terrible things happening in the world, it's like, what else can we do to, what other things are people not thinking of?
And I actually don't think going green is a new trend. I think people who are kind of setting the trend 20, 30 years ago really kind of paved the way. And I think what's happening now is there's almost a dire situation where we all realize a little bit better the impact we're having, and we all think about maybe some smaller things we can do to reduce that impact. And so while it's not a new trend, maybe it's a blossoming trend, but ultimately anything we can do, not just to better our own experience, but also the experience of others by teaching, by educating, that's important to us. I think with each piece of the project you do, you learn something that just wasn't obvious. And so for us, we're going to full electrification in the house. That means a significant draw of electricity. Replacing fossil fuels, you're replacing those with electricity. Now we source all of our electricity through the town of Lexington. We use the green option, so we feel good about at least offsetting our electric usage with green energy, but that doesn't mean we're not using a lot of it. Yeah. And I think it's hard for people to necessarily understand that by moving to geothermal or to air source heat pumps, you're actually going to use more electricity, but you got to use it the right way. And so we've really spent a lot of time thinking about how we're going to best understand our electric usage. So one of the really cool things we're putting into the house is not just solar and not just battery backups, but we're installing load centers that are called smart load centers. And they're from a company called span.io. And these load centers allow us to actually look down to a circuit by circuit level and understand every single piece of equipment and what it's drawing in terms of energy usage. We can monitor it. We can know when things aren't working well. We can also remotely control them and shut them off. And knowing that our grid is less stable today, as energy spikes and maybe the grid falters, when we switch to our battery backup, these smart load centers will automatically take over and start to prioritize different circuits in the house and shut off the things we don't need. So we can maximize the duration that we can exist in a power outage. So things like that, we didn't know 6 months ago. We've learned along the way, but we've really tried to incorporate them as we learn them. And we think it's important that you think about that energy usage as you make these selections of green products.
Likewise, we had assumed that we would put a gas stove into our new kitchen, and then just became aware of the dangers and environmental issues with natural gas, otherwise known as methane, and just how much more efficient induction stoves are, as well as being electric, fossil fuel free. I feel like there were just several things. And refrigerants. I listened to the How to Save a Planet podcast while I'm puttering around the garden. They had an entire hour-long episode about the impact of HFC refrigerants, but who knew the impact. They've recently changed the laws around this, but that is like another thing that, we should look into that when we're getting a new refrigerator. But unfortunately, what I wish is that there were like a showroom where you could go and see all these samples and see all these products and have these comparisons. So they're a business idea for someone.
My hope for this house is we have a great living experience for our family. We have 2 kids. Mm-hmm. We want to enjoy the space, but we also want to feel good about the space we're living in. So that's kind of the primary desire here. At the same time, it would be wonderful if we kind of help others make decisions that take them a little more green in their construction. So working with our great builders, our great architects, like they really have worked with us to think through every single aspect of it. And I believe that they're learning as much on these projects as we are, and hopefully they take those off to their other projects as well.
And that we can collect enough data along the way or through instrumentation built into some of the systems that can help other people make decisions and learn from that as well, the ripple effect.
Mm-hmm. My name is Matthew Kushel. I own Boss Corp Design and Build. We're the contractor, the general contractor on the project. We've worked with Joshua and Rachel dating back for 10 years. And we've worked closely with SV Design, the architectural firm, on the project to design everything from the foundation up. I think one of the keys that I want to have everyone take away from today is that it's really a team process. It involves all the stakeholders, from the town in the permitting section. The homeowners really pushed us in this case to be on the leading edge, the designers and the architectural firm as well, us as the builders. And I think a very important point for everyone is that in addition to designers and engineers, a great resource for a lot of the latest information, the most accurate information on these types of building applications is going to the manufacturers. For example, Rockwell, who we'll talk about with all the envelope construction, companies like them have very large research and development departments, very large engineering budgets where they put into all the design of this. They can answer questions very general to the very specific in your application. So really, I encourage everyone to reach out to them throughout the process. For the process of reducing the negative environmental impact of construction, not only from the construction process, but also from the energy use throughout the home, throughout the use of the home, we really want to look at it from all phases. So the earlier you can start in the design process, the better. It's certainly never too late, and it's not an all or nothing. This project in general is great because it takes everything from foundation all the way through roofing into the finish selections, but you can certainly pick and choose. I will say, as much as you can plan it early with the design team, with the architectural team, speaking to manufacturers and getting their envelope design, the better. But again, it's never too late to start. Sure, so from this house, from the green perspective, it really starts, as I mentioned, at the foundation. That goes from extra insulation on the exterior of the foundation, including under the foundation as well, the exterior walls, as I mentioned. We carry that all the way through the envelope on the exterior of the roof and the walls. We can look at some physical mock-ups of that construction in a moment. It also carries the insulation all the way on the interior and then carries all the way through to finish selections. We can talk about using reclaimed wood flooring throughout, recycled materials for the exterior siding, the roofing, recycled material for the countertops, other finish selections like that as well. So it really is an entire comprehensive package of the entire property. One of the things we have here is a physical mock-up of the particular construction building envelope in this home. Right here is the first layer of plywood. On the inside of this will be the closed cell spray foam of the walls, of the roof. And at this plywood is where typical construction would essentially end. On top of that, we have this product by Rockwell. It's called Comfort Board 80. So it's a Rockwell-based insulation product. It adds 4.2 R value per inch. We have 4 inches total, 2 layers of 2-inch here. We have our framing members to keep an air gap between the hot and the cold roof in this application, and then a second layer of plywood with underlayment, moving all the way to the roofing shingles, which are a recycled-based product produced by a company and a plant that aims for net zero in their production process. So again, as you can see, it's an entire systems-based approach. And to reiterate again, reaching out to the different manufacturers, such as Rockwell and EnviroShake, the producer of these roofing shingles, they become great resources to help the design team engineer this. So here we have a physical mock-up of the wall construction. Again, starting from the inside here, we have the closed cell spray foam insulation and then our exterior sheathing plywood. In a typical construction, this is where that envelope would end and the siding would be attached right to that. In this application, we have the Rockwell insulation, a layer of 3-inch here. We have what we call a rain shield that provides protection against moisture and air. And then we actually have a product by Richlight, which is a recycled-based siding product here. So again, you can see not only from an insulation value, but from the using recycle-based materials in both the siding and the trim to reduce the environmental impact of the construction and then of the future use of the home as well. Yeah, I think a couple great things you could look at as standalone projects. One of the probably most effective is insulating your roof, your attic space. If you don't have that already, there's incentives for that. There's lots of companies out there that can provide quotes for free, energy assessments as well. That's a very high impact project that can be isolated without really disrupting your active living space or anything. Other options for projects like that are looking into your appliances, using induction as we are in this project, using heat pump-based dryers as opposed to either fossil fuel-based or other electric-based conventional ones. And on the finish end, again, using reclaimed product and recycled-based product as well. I think one of the most exciting things about this trend moving to the green building is that we all share the concern of reducing our impact in our daily lives. Here we're doing it at work for the environment. Construction has a significant environmental impact, usually very deleterious. So the more that we can do to reduce that in the construction process, and then also for the end use of the home, we can certainly all feel better about that. I think the most exciting thing about this particular project is the HVAC use and the amount of recycled-based product that's going in. I mean, the entire home on both floors is going to have literally torn down barns reclaimed as the hardwood floor. And then the recycled-based product for the exterior siding is something we haven't worked with prior, and I think will be a lasting trend. So the only other thing I think I want to say is one of the other key points is things that might have been preconceptions as very recently as 1, 2, 3 years ago can be totally changed. People thought with certain types of electric-based heating, electric-based cooking, some people had a negative connotation with them. Everything that you might have heard 3 years ago can be totally changed. Same thing with insulation, the type of insulation, the way it's processed. So if you're undertaking a project as a builder or a homeowner, or as an architect, really look in, even as often as every 6 months to see the current state of technology and product availability.
So I'm standing here in front of one of the air source heat pumps that serves the living conditions of this house. We're looking at a vertical mounted unit, and this unit has the ability to have refrigerant pipes connected to the outdoor heat pumps, and it also has, in the case of an extremely cold situation, the ability to put some backup electric heat on those very cold days, a handful of days per year. Another element of this system is the high efficiency air filter that's at the bottom, so as air comes back from the house and back into the system, it's filtered before going out. We have also on this residence horizontally mounted heat pump units. This is the horizontal configuration, and it's a little bit more streamlined. It's for smaller areas, in this case a smaller zone. Over here we have a air source water heater. It's the second of the 5 forms of heat pump systems that we have here. This takes air from the basement to heat the water, and in the process cools the basement and dehumidifies at the same time. We're up on the 2nd floor now, and a couple things I'd like to point out is we have up in this area an ERV, which is an energy ventilator recovery. We also have one of the air handlers. And you'll also notice a lot of the ductwork that's up on here. The first item, the energy ventilator recovery, does a couple things for the house. One is, because the house is so tight, we want to be able to make sure that we exhaust stale air in the form of carbon dioxide from people breathing, and also any odors, cooking odors, bathroom odors. So we pick up all of those air that we want to throw away up in this unit, but before we throw it out to the outside world, we capture as much heat energy and as much humidity energy out of that unit, out of that air, and we impart that energy back into the air that's coming back in to freshen up the house. You'll notice up this ductwork, we see a lot of ductwork that's up close to, or in some cases up in the rafter space. And what's important is the envelope that the client is building with their builder here allows us to do that, because we still are inside the envelope of the house, so we don't have to worry about energy being lost to the outside world, which means we can take advantage of spaces, interstitial spaces like this that would otherwise be unuseful to the client, and we can put our equipment up in this area.
Well, I have big hopes. I hope that my grandchildren, who are 5 and 8, do not have to worry about climate change, that at some point everybody has adopted clean energy, adopted clean building solutions, clean transportation, which is another whole piece. So once we start to decarbonize, maybe we can start to settle down the climate change advancement, and then eventually hopefully we can reverse it with some natural solutions like trees and native plantings. So there's a lot to be done. Everybody can do their part and do 1 or 2 little things. They may be little to you, but when you add them all up, we have a great big sea of change.